Now let's talk about Lagrange multipliers method. In Lagrange multipliers method, sometimes we have a function which is restricted, limited to some other functions. So optimization. Using Lagrange multipliers method. So what's the idea behind it? Here, to find the maximum and minimum values, find the maximum or minimum value of a function. So the function that is given to us is, for example, f of x and y. You can add z as well and generalize the function later. So note that f of x and y or f of x, y, and z. Subject to. It means that we are bounding our function to some other functions. It might be the finance that we have restriction on, or the materials that we have restrictions on, subject to the constraint. The constraint that we have is g of x, y, or g of x, y, z equals to a constant like k. Suppose the gradient of g is not equal to 0. Then this method, the Lagrange multipliers method, says, hey, to find the maximum minimum value of this function, what are you going to do? You're going to set the gradients almost equal to each other. The gradients for the vectors, the gradient of f and the gradient of g, must be parallel to each other. So take a look at this. Set the gradient of f equals to a Greek letter lambda times gradient of g. So what are we trying to do? We're trying to find the values that make these two vectors parallel to each other. So we're using a numerical value like lambda that help us to solve this problem. And also note that you have a constraint. It means that g of x, y, and z is equal to k. We're going to use this equation later to help us solve for x, y, and lambda. Then evaluate s. Evaluate the function f. Guys, remember that you're trying to maximize or minimize f, the function f, at all points that you found here. Okay, very good. So what are some examples here? Guys, you only have one calculus part and the rest is algebra. So don't overthink it. You need to know how to perform algebra. So give us an example. Sure, take a look at the following example. In this example, I ask you, well, find the extreme values. Find the extreme values of what? Of this function, f of x and y, which is equal to x squared plus 2y squared, subject to, on this circle, x squared plus y squared equals to 1. This is what we're trying to maximize or minimize. All right, very good. In the very first step, we need to find the gradient of these two functions. So The Lagrange multipliers method says, hey, I need to find the gradient of f and gradient of g. So this is my f. I can find the gradient of f this way. I need to find partial derivative of f with respect to x, partial derivative of f with respect to y, right? Which is equal to f of x, 2x, comma, f of y, 4y. And also I need to find the gradient of g. So these are important steps. The gradient of g is equal to, well, g of x and g of y, which is 2x, comma, 2y. So, guys, make sure you're using the correct symbols. Do not use parentheses. Do not use parentheses. It's going to be wrong. So when you're using vectors, you're representing vectors here. It's not points. Perfect. So now let's go back to the method. Gradient of f is equal to lambda gradient of g. Okay. 2x, comma 2, sorry, comma 4y, let's write down 4f here, equals to lambda, well, the gradient of g, 2x, comma 2y, and also we have our constraint. So make sure you know that you have your constraint because eventually we're going to use this. It helps us to find one of the variables. And also x squared plus y squared is equal to 1. So here, what's the meaning of this step? It says, hey, the very first vector with 2x and 4y as its components is equal to 2 lambda x and 2 lambda y. All right, so two vectors are equal to each other. It means that the very first components must be equal and the second components must be equal. So 2x must be equal to 2 lambda x, and also 4y must be equal to 2 lambda y. Well. So what do we have here? We have the following scenario. I'm going to write them down here. 2x is equal to 2 lambda x, and 4y is equal to 2 lambda y. I'm just writing these two equations down here because eventually you're going to use this relation as well. Well, okay. From this equation, guys, pure algebra. We don't have any calculus anymore. It says, hey, 2x is equal to 2 lambda x. How do you solve this equation? 2x minus 2 lambda x is equal to 0. So I can factor out 2x. 1 minus lambda is 0. So what's the meaning of that? It means that 2x is equal to 0, or lambda is equal to 1, x is equal to 0, or lambda is equal to 1. But if x is equal to 0, from this relation, we get 0 squared plus y squared equals to 1, or y becomes plus minus 1. So 0 and 1, the second point, 0 and negative 1. There you go. Note that we use x equal to 0 and use the constraint to find the values for y. Now, what if lambda is equal to 1? If lambda is equal to 1, from the second equation, you get 4y equals to 2y, which is true if and only if y is equal to 0. So when y is equal to 0, we go back to the constraint again. X squared plus 0 squared is equal to 1, or x squared is 1, or x is plus minus 1. So x is 1, y is 0, x is negative 1, y is 0. So how many points? 1, 2, 3, and 4 points. Then evaluate the function f at all points. Okay, so this is my last step. In the last step, I'm going to plug everything in to the function and compare these values. So at 0 and 1, f of 0 and 1 is equal to 0 squared plus 2, 1 squared, which is 2. At 0 and negative 1, my f of 0 and negative 1 is 0 squared plus 2 times negative 1 squared, which is 2 again. So far I calculate z or f at this point. I calculated z or f at this point. Now I'm going to calculate f or z at 1 and 0. At 1 and 0, my f of 1 and 0 is equal to, guys, again, remember, we are finding the extreme values of this function. I'm not working with this function. This is constrained. This is fixed. I need to find the z values here. 1 squared plus 2 times 0 squared, which is 1. And at negative 1 and 0, f of negative 1 and 0 is equal to negative 1 squared plus 2 times 0 squared, which is 1 again. So which one is maximum? Which one is minimum? So obviously 2 is larger than 1. So what are you going to say? You're going to say that, hey, this function has maximum value, all right, which is 2. The maximum value of f is 2, and the minimum value of f is 1. This is your final answer. You might be interested in finding the maximum and minimum value of this function over other constraints. This is the given constraint to us. This is our unit circle. And we found the maximum and minimum of this function restricted or constrained to x squared plus y squared equals to 1. If I change it to x squared plus y squared equals to 2, then your calculations are going to be different. Your points are going to be different. The z values are going to be different. So make sure to be able to identify your constraint so you can do the computations correctly. And as you saw, we only had a little bit of calculus here. The rest is pure algebra.